All right. Literally, all right. Right triangles. That's all we're going to talk about today. All right, right triangles. Here we go. First, Pythagorean theorem. You've already learned about this a little bit. Just to review real quick, we know that it's a squared plus b squared equals c squared. So a pretty easy formula to memorize. And we know that the a and the b are always going to be what we call the legs. And it doesn't matter which one you call A and which one you call B. You can flip those back and forth, doesn't matter. But what does matter is that our third side, which we call C, is always the hypotenuse. And we always know where the hypotenuse is because it's always across from the right angle. So the hypotenuse, it's the longest side, it's always across from the right angle, and it always has to be our C in a squared plus b squared equals c squared. And as a side note reminder, Pythagorean theorem only works with right triangles. So if it's not a right triangle, don't use Pythagorean theorem. It won't work. All right, so we're going to do a couple of examples. We're going to identify our A, B, and C. And the important part is just identifying C. So I know that C in this problem is x, because x is my hypotenuse. So 6 and 8 will be my legs. And it doesn't matter which one I write first. So maybe I choose to put 6 as my A and 8 as my B. That's totally fine. If I flip it, I'm going to get the same answer. So to simplify, 6 squared is 36. 8 squared is 64. X squared, it's just x squared. And then we can combine 36 and 64. And then our end goal is to get x alone, so we still need to get rid of the squared. So we take the square root. And the square root of 100, you can plug that in your calculator. Or square root of 100, most of us know that's 10. So it's the square root because it's a number times itself that gives us the original. So 10 times 10 is 100, so the square root of 100 is 10. All right, so our hypotenuse for this problem had a length of 10. Now this is where you have to be a little bit more careful because this time we're not solving for the hypotenuse. Our hypotenuse is 5. So when I write out my equation, I know my C already. My C is 5, so I need to make sure I put that there. And then these are interchangeable for A and B. So I'm just going to do it x squared plus 3 squared. Could also do 3 squared plus x squared, same thing. And when I simplify it, 3 squared is 9, 5 squared is 25. Get the x squared by itself, so subtract 9. And these problems are working out with nice whole numbers, makes it easy to calculate. Square root of 16 is 4, and the square root of x squared, right, that undoes the square, so we just get x. So x equals square root of 16, which is 4. All right, nice and easy. With this problem, we're going to run into something a little bit different. I'm still going to set up my a squared plus b squared equals c squared. I know that 10 is my hypotenuse, right? It's across from the right angle. So I'm going to make sure to plug 10 in for C. And then these are my 2 legs, so I can put them in any order. So I usually like to put the variable first, x squared plus 5 squared. Simplify it, x squared plus 25 equals 100. Subtract 25. And I get x squared equals 75. Now when I get to this point, when I go to take the square root, I get x equals, but 75 is not a perfect square. There's no whole number that multiplies by itself to get 75. So I've got 2 options. Option 1 is I take my calculator, I go find my square root button, and I put in 75. And I find the square root of 75 is about 8.66. So I can leave it as a decimal, right? 8.66. We know that's between 8 and 9. Or sometimes you'll be asked to simplify the radical. To simplify the radical means we're going to break down the square root of 75 into its simplest form, which will be useful for when we're solving some problems down the road. So even though 8.66 is quick and easy, and I kind of like the decimal because I know 8.66 is bigger than 8, smaller than 9, simplifying the radical has advantages as well. So I'm going to teach you how to simplify the radical. I'm going to start with 75, and I'm going to use my prime factors, or the factor tree. So in order to use my factor tree, I just need to come up with any numbers that multiply to 75. So off the top of my head, I go, oh, 75 cents, that's 3 quarters. So 3 25-cent pieces, or 3 times 25 is 75. But 3 is a prime number. I can't break it down, so I'm going to circle it because it is a prime number. But 25 I can simplify. To get 25, I can multiply 5 times 5. And I'm going to circle the 5s because 5 is also a prime number. So I can't multiply anything to get 3 other than 3 times 1. And I can't multiply anything to get 5 other than 5 times 1. So I have reached prime numbers. Once I get down to my prime numbers, I look for pairs. Because if I multiply these together, 5 times 5, I get 25. The square root of 25 is 5. So if I have a pair of prime numbers that are the same, I can actually take the square root of what they multiply to and move it to the outside. Or, long story short, if it has a buddy, they get to go outside and play. But the 3 does not have a buddy. It does not have a pair or a match. So he's going to stay inside the house. So when I simplify this radical, I end up getting 5 times the square root of 3. I'm going to show you a few more examples of this, and then you'll work on it in class with your teachers as well, so you can ask more questions in class. All right, square root of 9. It's a perfect square. We don't even have to do anything. It's 3. But I could also think about it as if I do my prime factors, if I do my factor tree, I get 3 and 3. And we said if we have a pair of the same number, they can go outside the radical. And then anything else would go inside the radical. But there's no numbers left. So 3 outside is the only thing we have. So square root of 9 is 3. With 16, I know square root of 16 is 4, right? I already know that that's going to equal 4. But if I use my factor tree, I would still get 4. And let me show you how. To get 16, I can do 2 times 8. Right? Or you might do 4 times 4. It doesn't matter what you do. You'll still end up with the same prime numbers at the end. 8, I can do 2 times 4. 4, I can do 2 times 2. So I'm going to put my square root down here, my radical. And anything that has a pair gets to go to the outside. So there's a pair of 2's, which means I get to take a 2 outside. But here's another pair of 2's. So I get to take another 2 to the outside. And anytime we bring out more than one number, we're going to multiply those together. And then did I have any numbers left to go inside the radical? I didn't, which means this one is a perfect square. So I can actually get rid of the radical. And then 2 times 2 is 4. So the square root of 16 is 4, which we already knew. But just showing you using the factor tree, we would still get the same answer. All right, here's one that's not a perfect square. I'm going to do my factors, so I can do 2 times 6. I could have also done 3 times 4. I like to use 2 anytime I can, though. I think it makes it a little bit easier. And then 6, I can do 2 times 3. And again, I'm circling these numbers that are prime numbers. I can't break them down any further. Once I've gone all the way and gotten all my prime numbers, I put my radical, or my house, and any number that has a buddy or a partner that's exactly the same, they get to go out and play. They get to go outside the house. So the pair of 2's buddy up, they go outside to play. But the 3, poor lonely 3, does not have a partner, so he's got to stay inside the house. So the simplified version of square root of 12 is 2 square root 3. All right, square root of 30 is a little bit unique. I can do 3 times 10. 3 is a prime number. For 10, I can do 2 times 5. 2 is a prime number. 5 is a prime number. So I found all my prime numbers, but do I have any partners? Is there anything that can go outside of the house? No, there aren't any buddies, right? So what we do is we take those 3 numbers and we just put them back inside the square root. And we just multiply them back together. So the square root of 30 actually simplifies to the square root of 30. It couldn't be simplified. We still tried, but there were no partners, so it remained square root 30. All right, square root 72. This one's got lots of factors. So I'm going to start with 2. 2 times 36. 2 times 18. 2 times 9. And then 9 I can do 3 times 3. So again, what I'm looking for is partners that can go outside. So 2 and 2, there's a pair of 2's. For every partner, I can take one of them to the outside. I have another 2, but it doesn't have a partner to match up with, so it's going to have to stay inside. And then I have a pair of 3's, and because it has a partner, it gets to go outside. Anytime we have multiple numbers on the outside, we multiply them together. So 3 times 2 is 6, and then we had square root of 2. All right, hope you're picking up on this, doing okay. Simplified. All right, let's go ahead and combine the Pythagorean theorem and simplifying radicals into the same problem with a little word problem. The bottom of a ladder must be placed 3 feet from a wall. All right, so let me draw a wall. There's my wall. Wall. And then I have a ladder that is reaching up to the wall. So it doesn't say how high on the wall, but I do know that the ladder is 3 feet away. So I'm going to set it up 3 feet away. And I do know that the ladder, right, here's my ladder leaning against the wall. That ladder has a length of 12 feet. How far above the ground does the ladder touch the wall? So we're trying to figure out what's the height from the top of the ladder to the ground. Well, I know that the wall is going to be straight up, so that creates a right angle. And I know 2 of the 3 sides of the right angle, which means I can use a squared plus b squared equals c squared. We can use the Pythagorean theorem because it's a right triangle. Now the most important question is, what is the c in this problem? That's right. C is going to be 12 because 12 is the hypotenuse, which is across from the right angle. So when I set up this problem, I'm going to put 12 squared where C was. And then the A and the B can be either order. So I'm going to go ahead and do x squared plus 3 squared. And then I'm going to simplify it. X squared plus 9 equals 144. Subtract 9. X squared equals 135. And then to get x alone, we need to take the square root. But 135 is not a perfect square. So I've got 2 options again, right? I can take my calculator and I can type in square root 135, which is 11.62 approximately. So I can say that the ladder is reaching up 11.62 feet onto the wall, or that's how high above the ground the ladder is reaching. Or we can do our factor tree and simplify the radical. So 135, well, I know 5 definitely goes into it. So let's see, 135 divided by 5 is 27. 27 I know I can break down into 3 times 9. And then 9 I can break down into 3 times 3. So based on those 4 prime factors, what would our final simplified radical be? Well, we know that we have a pair of 3's. So a 3 can leave the house. And then we have a 5 that doesn't have a pair and a 3 that doesn't have a pair. So they're just going to go back into the radical. And anytime we have more than one factor inside, we're going to multiply those together. So this becomes 3 root 15. So 3 root 15 and 11.62, those are actually the same exact number. It's just a different way of showing it. Kind of like if I have $1, I might have $1 bill, or I might have 4 quarters. But either way, their value is still $1, right? 11.62 and 3 root 15, they're both the same size.